So one of the things that we've already learned how to do is how to multiply using the area method. So for example, if I was trying to find the area of this rectangle, it really involves me finding the area of the two smaller rectangles on the inside. So for example, this area would be 2x squared because it'd be 2x times x, and this area would be 10x because it's 2x times 5. And then in the second area, this would be 3 times x, so 3x, and this area would be 15. So in order to find the total area, we'd simply multiply, or we'd add those two smaller rectangles together. Today the objective is to go ahead then and push that forward into just using the symbols that we saw in our multiplication problem over here on the side, 2x plus 3 times x plus 5. So notice that the purple rectangle is really this 2x tall, and that is being multiplied by this entire binomial. So I'm going to go ahead and write that out. It's 2x, and then I'm multiplying that with a binomial x plus 3. So I'm essentially using the distributive property here. And then we're going to do the exact same thing for our green rectangle, which has a height of positive 3, and I'm going to be multiplying that with this entire binomial x plus 5, which is the width of the green rectangle. So I'm going to write plus 3, and then I'm going to do that exact same x plus 5. So that is the distributive property, and that was one distribution, but of course that means that we're going to then have to multiply the 2x through. So 2x times x, that distribution right there, is 2x squared, and then we'll do the same distributions. Let's go do that in purple. So 2x times 3 is plus 6x. Those little arcs are not necessary, but you might want to use them to help you. And then for the rest of this, that would be plus 3x, and then plus 3 times 5, which is 15. So essentially we are distributing for a second time. So we've done the distributive property twice, which is why we're going to refer to this as the double distributive property. And then we'll simply combine any like terms that we might have to write our expression in its simplest form, which in this case, those are your two like terms. So we've got 2x squared, we've got a total of 9x, and then we have 15. So up until now, we've gotten that same answer by just simply looking at the area over here by actually using a picture of it. But now our expectation is that we can draw it all in symbols. And yes, you do need to show all 4 of these lines. I am not interested in the final answer. I am interested in the process that you go through and in showing all of those steps to really understand what you're doing when you're doing the double distributive property, and more importantly, so that eventually we can go backwards. So let's go ahead and then take a look at what we mean by that in comparison with the properties you already know. So the distributive property you already know says that when you do 3x times x minus 6, that's really saying the height of the rectangle is 3x and the width is x minus 6. So that would require you to do distribution, which you've been doing all year, to get you 3x times x, 3x squared, minus 18x. And that's again simply 3x times x is 3x squared minus 18x. So that would be your expression, and that expression is exactly the same value. We'd say those are equivalent expressions. There are two ways of writing the exact same thing. They still have the same value. So the only difference for today is just simply to say that when you have a binomial times a binomial, that's going to be 3x times that whole thing. So again, 3x, and then the binomial means that it's x minus 6 wide. And then you're going to have the same thing. This 1 is going to multiply, but it's going to multiply with the whole thing, the whole term, or sorry, excuse me, the whole second binomial. So that would be 1 times x minus 6. And that's really all there is to it. So you simply write it out. 3x times x minus 6 plus 1 times x minus 6. And notice I'm not color coding here, but hopefully you're seeing each of those two terms. So that's the 3x, and that's the plus 1. And then you would just simply continue to distribute again, which are the little individual areas. So minus 18x plus 1x minus 6. And then condense your like terms, 3x squared minus 17x minus 6. So that's the double distributive property, which means that we've just done it twice, so that doesn't keep us from doing more advanced stuff like the triple distributive property. But I'm going to go ahead and leave that to you for the moment. I think you could probably figure out what to do with that. Basically, you're going to have, actually, excuse me, it's not triple distributive in this case. It's still just double distributive, because we're going to distribute this with this whole term, and then we're going to go ahead and do the same thing. We'll have our plus 3 times that trinomial. So if you were going to tackle that problem, it'd be x times x squared plus 2x plus 4, just the distributive property, plus 3 times x squared plus 2x plus 4. And then I would go ahead and distribute and then simplify, but I'm going to leave that problem undone for the moment. I'll let you finish it up.